Welcome back to Akim Academy, ladies and gentlemen. This is the third section on Surd, okay, or the part 3 of the videos on Surd. Last time we looked at how to simplify surds and also the addition and subtraction of surds. As you can see, we have 2 examples over here. Okay, let's use this one as a revision. Now, one thing we have to notice that when you come to the breaking down in terms of examination, okay, you can put these ones on your calculator and the calculator can reduce it for you, okay, in terms of examination, and you have to be fast over there because there's no time over there. So you can use your calculator to point this one so that it will reduce it for you. You point this one, it will reduce it for you, but make sure you don't use the decimals, okay? We deal with surds and everything should be in surds. Don't use decimals. If you punch it, the calculator will reduce it in a surd form, okay? You can do it in that way, but also you are now familiar with the process of what? Reducing it as well. So when the calculator gives you the reduction form, you are aware, or you know the process or how the calculator managed to reduce it in that form for you. Okay, so with this one, you can go straight and you know that 25 times 2, right? I think we can find a common non-perfect square which can run through, which will be 2, okay? So 25 times 2 over here will give us 50. And square root of 25 will give us 5. Root 2 remains in the radical sign, okay? Minus, here is 72. And I think 36 times 2 should give us 72. So square root of 36 should give us 6. Then the 2 remains in the radical sign. Then over here, we have 32, which will be 16 times 2. Okay, 16 is perfect, 2 is non-perfect. So 16 square root of 16 is 4. 4 root 2. Okay, so from here, we know that 5, because the values under the radical signs are the same, then we are good to do the addition and subtraction. Okay, so we have 5 minus 6 will give us minus 1, plus 4 should give us 3 root 2, okay, as our final answer. Okay, so this is how we did it. You have one over here to use as your revision on your own. Okay, now let's come back to today's problem. Today we are looking at multiplication and division, okay? But for division, we will look at division properly in our next video, okay, which is rationalization of what it says. So here, our main focus over here will be on the multiplication, okay, how to multiply 2 surds or 2 values involving surds, okay, good. So at this point, let's look at the first part, which is example 1, okay. We have root 2 multiplying root 3 all to the exponent of 3, okay. So at this point, what you have to do is you first have to expand root 3, which has an exponent, before you can multiply it by this one, okay. So in this case, we may have so root 3 all exponent 3 simply means root 3 is multiplying itself 3 times, okay. Root 3 is multiplying itself 3 times, so you have root 3 times root 3, okay. It's multiplying itself 3 times, that's exponent 3, okay. Now in terms of multiplication, whenever you realize that you are multiplying 2 surds and the values under the radical signs are the same, when you multiply it, you should get the same answer. You should get the same what number over here, okay. So meaning that root 3 times root 3 should give us 3 straight away. Root 3 times root 3 should give us 3, or root 3 times root 3 will give you root 9, and square root of 9 is 3. Okay, that's why whenever you realize the numbers are the same, when you multiply them, you should get the same number. So here we are going to have root 2 multiplying 3 root 3. Okay, 3 root 3. Now, in terms of multiplication, when the values under the radical signs are not the same, we can still multiply. When the values under the radical signs are not the same, whether they are the same or not, we can still multiply. Okay, so here what we do is, we don't multiply the rational by the value under the radical sign. We multiply rational by rational, then the surd by the surd. Okay, so here you could see there's a rational here which is 1, but we don't write it. So 1 times 3 is 3, then square root of 2 times square root of 3. Okay, for multiplication we can multiply it and we'll have root 6. Okay, we have root 6, and this becomes our answer for the first example. Okay, so if you look at it, you can use the same principle over here. This one looks a little bit simpler, whereby you multiply your 4 by the 1 over here, which is a rational, then the square root of 3 times square root of 5. I think it's easy for you to do that one. Here too we have 2 root 8, all exponent what? 3. So 2 root 8 should multiply itself 3 times. Okay, then after that you can multiply the rationals as well as what? The irrationals. After that you could see that the 8 can be in higher value. Okay, so what you have to do is you have to reduce the value of it after you are done with it. Okay, you have to reduce it to its simplest form. Good. Now let's look at the binomial multiplication over here. The binomial means you have 2 numbers over here, or let's say 2 terms, first term, second term. Here too we have first term, second term. Now we use the same principle when you expanding binomials. Okay, you take the first one, multiply by this, then you come and take the second part, you multiply by this, you multiply by this. After that you simplify. Okay, after that you simplify it. Good. So we have example 4 over here. Okay, so for easy calculation you can split them if you want to. So we can split them and take 6 root 3 multiplying everything over here. Okay, so we have 5 root 3 minus plus 4 root 5. Okay, then we can come to the second section. We'll take minus 2 root 5 minus, okay, multiply with everything over here. Root 5. Okay, you can split it like this and it will be easier for you. So let's do the multiplication. 6 root 3 times 5 root 3. Okay, now the rational multiply the rational, irrational multiply the irrational. Okay, so 6 times 5 will give us 30. We put it down and they are multiplying, so you bring the multiplication sign. Now root 3 times root 3. Okay, root 3 times root 3, because the values under it are the same, you just write 3. Okay, root 3 times root 3, 3. Good. Then we come to the next section. 6 times plus 4, we have plus 24, and because they are multiplying, so we have our multiplication sign here. So we have root 3 times root 5, which will be root 15. Okay, which will be root 15. Then we come to the next part over here, minus 2 root 5 times 5 root 3. Okay, so the rational multiply the rational over here. 2 times 5, which is 10. Okay, multiplying what? Root 5 times root 3. Okay, so root 5 times root 3, we have root 15 over here. Okay, then the last part, minus 2 or 2 times 4. So 2 times 4, which will give us minus 8. Then root 5 times the root 5 over here. So root 5 times root 5, because they are the same, we have the same numbers under the radical sign, we are going to get straightforward 5 over here. Okay, straightforward 5. So at this point, we are done with expansion. We can simplify. Okay, so we have 30 times 3, which should give us 90. Okay, now here we have 24, so we have plus 24 root 15 minus, so here 10 times root 15, you have 10 root 15. Okay, then here you have minus 40. Okay, minus 40. Now, so you can see some similarities over here. 90 is rational, minus 40 is also rational, so they can do the subtraction over there. We have 50. Okay, so 90 minus 40, we have 50. Okay, then 24 root 15 minus 10 root 15, you can see the numbers under the radical signs are the same. Whenever it comes to addition and subtractions, make sure the numbers under the radical signs are the same before you can do the addition or subtraction. So thank God, here we have root 15, here too we have what? Root 15. So they are the same, therefore we can do the addition and subtraction over here. Or here we are doing the subtraction. So 24 minus 10 should give us plus 14, right? 14 root 15. Now, so at this point you can see that this 15 is an imperfect square number. We cannot reduce it as well, though it's a little bit huge, but we cannot reduce it. So we will leave this as our answer. Okay, so from this expansion, we have 50 plus 14 root 15 to be our answer. So when you multiply this thing over here, okay, this is what we are getting, which is 50 plus 14 root 15 as our final answer. Because at this point, there's nothing you can do again. Don't go and add these two. Okay, don't go and add it. 50 and 14, they are not the same. So never try of adding it. Okay, they are not the same. Because here has a square root of 15, here has no square root of 15. So you can't add the two. Let's take note of this. Students make a lot of mistakes on this. Okay, good. Good. In that case, I hope you can use the same principle for question 6. Here we have only one, this is a rational number over here, plus root 7 times 3 plus root 5. I hope you can do this one over here using the same principle as this one. You can split it if you know you cannot use your head and to multiply them. At times, it can escape you and so on and so forth. So you can split it in this way. You take the first one, the first section over here. You take 6, multiply by this 2, plus root 7, you multiply by this 2. Then you expand it and simplify. Okay, the same applies to question 5 over here. Example 5, we have similar question over here. You take 3, multiply by these 2. Okay, after that, you bring your plus root 2. Okay, then you multiply by the 2 over here. The same principle as we did over here. Use the same steps over here, and you'll be able to draw it. Okay, good. Let's try question 7, which is a little bit different, but they are all the same. But so we have 7 over here. Good. So here it is already, we have only one item, which is multiply this binomial over here. Okay, only one item. So what we do is we multiply root 3 by 2 root 3. Now, as I just stated, we multiply the rational by the rational, then the irrational by the irrational. Okay, so 1 times 2, what are we going to have? We have 2. Okay. Okay, so here we have root 3 times root 3. Okay, so after the 1 times 2, we have 2 over here. So root 3 times root 3. Now you can see that those under the radical signs are the same. And therefore, straight away, I can say times 3. Okay, times 3. Because 1 times 2, root 3 times root 3. And the root 3 over here is, we have 3 inside the radical sign. And therefore, straight away, I'll just say 3 over here. Okay, good. Then we are done with the first section. Let's multiply this by this section. Okay, Now, you can see that this a fraction. This is a fraction. And this is a whole number. Okay? This is considered as a whole number because it is standing alone. Okay? And whenever you are multiplying a whole number by a fraction, what happens? We multiply the whole number by the numerator. Okay? By the numerator. Or better still, if you think you have a problem with that, you can just bring one here. You underline this one, bring one here. Okay? So it means using the principle of multiplication, numerator times numerator, denominator times denominator. Have you seen that? So you have root 3 times 2 over here. And we're going to have root 3 times 2, we have 2 root 3. Okay? So this, the 1 over here will multiply the 2, then we add the root 3 to it. So making 2 root 3. Okay? Then 1 times root 3 over here will give us root 3 as we have over here. Okay? So here, if you simplify it, we have 6 plus 2 root 3. Okay? Out of root 3. Okay. Now, at this point, we have to simplify this one because we have a surd. Okay? A surd as a denominator. And you know, in terms of mathematics, we don't like it or we don't want it when we have a surd as what? A denominator. Okay, so we have to simplify these ones again so that we can change the surd here to what? A non-surd, or should I say a rational. Okay, in our next video, we are going to look at that, which is rationalization of what? Surds. We will look at that one. We'll focus on that one much. Okay, but here let's apply some more here. So here what we have to do is we can bring one here, okay, and find the LCM. Okay, so after the LCM, the LCM will be root 3, right? So 1 will enter into root 3 how many times? Which is root 3. Root 3 times 6, we have 6 root 3. Okay, good. Then plus root 3 will enter into the LCM, which will be root 3, 1, and multiply by the numerator, we have 2 root 3. Okay, everything out of the LCM, which is root 3. I hope you're okay here. Now, so what I was talking about as the rationalization. So what do we do? Here you can see there's a surd here, and we don't like it when there's a surd as a denominator. Okay, we don't prefer leaving your denominator as a surd. So what you have to do is you multiply both the numerator and the denominator by the denominator itself. Okay, so you multiply root 3 by this, by the numerator, then you multiply the denominator also by root 3. So we are just multiplying both the numerator and the denominator by the denominator over here. Okay, good. So in that case, then we are going to have here you can see this is a binomial and we are expanding again. So root 3 here times the first one. Okay, then the root 3 again times the second part. Okay, so root 3 times 6 root 3. So you can see we have 1 here. So 1 times 6, we have 6. Okay, then we have root 3 times root 3, which should give us a straight answer to be 3. Okay, good. Then we come to the second part, plus 1 times 2 over here, we have 2. Then root 3 times root 3, which should give us a straight answer as 3. All out of root 3 times root 3 is also giving us a straight answer 3. Now you can see that the surd has vanished from the denominator. Now we can go ahead and simplify it. We have 6 times 3, which is 18, okay, plus 6 out of 3. Okay, so at this point, we have 6 plus 18, which will give us 24, right? Okay, 24 out of 3. And this one should give us a straight answer of 8. So you can see that here, if you do the simplification over here, when you simplify this, we are getting a straight answer of what? 8. Okay, straight answer of 8. This is interesting. It's interesting. Just take your time, go through it, take your time, and try your hands on those that I left for you. Okay, and as time goes on, you become conversant with them. Okay. So what we are going to do is you try your hands on the rest. We have example 3 here, example 6, then example 5 as well. Okay, just try your hands on them. Next time when we meet, we are going to look at the rationalization of sets, which involves a lot of divisions. Okay, that's where we'll be looking at the division aspect a lot. Okay, so just use the principle that we use over here to simplify the rest over here. And I hope this one helps, and just don't forget to subscribe for more interesting videos, especially for the next part, which will be more interesting than this one. Okay, just take care and have a nice day. Bye bye.